Hi there and welcome to this Integrated Math 2 video series. This is lesson 2 in Unit 3. If you haven't watched Unit 3 lesson 1 yet, make sure to go back and do that first. Because what we do today is going to really lean on what we did back in lesson 1. And so make sure and go back and watch that first. So before we get started with our lesson, go ahead and try these 3 warm-up problems. Okay, so number 1, we're converting from, this is factored form to standard form. And to do that, we're going to do what we did last video, which is multiply 2 polynomials. So we have this binomial, x plus 3, times this binomial, 2x minus 1. So when we do that, we're going to have x times this whole second parentheses and 3 times this whole second parentheses. And so we get x times 2x minus 1 plus 3 times 2x minus 1. So if we distribute the x in here, we're going to get 2x squared minus x plus 6x minus 3. And so when we combine like terms there, those 2 middle terms are like terms. So we're going to end up with 2x squared plus 5x minus 3. All right, now in number 2 here, we're going to do kind of the same thing. When converting from vertex form to standard form, we really do the same thing with the squared term here, because x minus 2 squared is x minus 2 times itself. And so we're going to distribute just as we did. The only difference is we're going to add 3 to the resulting polynomial. So when we distribute this, we're going to get x squared minus 2x plus 4, and then the plus 3. So that's going to leave us with x squared minus 4x plus 7. All right? So very similar to number 1. In number 3, you're trying to match up which of these quadratics could be graphed to the left there. We don't know the numbers that are involved. We just know that the vertex is in the 3rd quadrant. One's a positive x-intercept, one's a negative. The y-intercept is a negative number there. So just based on that information, which of these quadratics could be graphed there? In the first one, there's a vertex of -2, -1. And so that could be the graph of that because it's in the 3rd quadrant. Here, this negative here indicates it's a concave down polynomial or parabola, and this one is concave up, and so we know that that one cannot be. So I'm just going to put an X through that one. This one has x-intercepts of -2, 0, and -4, 0. So that's 2 negative x-intercepts, and we see that that's not the case here. This one has one x-intercept of -3, 0 and an x-intercept of +5, 0, which could be the case here. This one in vertex form we know has a vertex at 4, -2. And so the point 4, -2 would be down here, and that is not where the vertex is. So that one cannot be. And then lastly, we have a standard form quadratic. It's got a negative y-intercept of -3, or 0, -3 right here, and it's concave up. So that could be potentially that graph there. So those 3 are the only ones that could be graphed there. All right, so let's hop into our lesson for today, which is taking a quadratic in standard form and converting it to factored form. And so we're going to use kind of in reverse what we did last lesson. So last lesson we talked about factoring, and in this lesson we're going to go in reverse. So we're going to start with standard form and see if we can convert it to factored. So to do that, I'm going to show you one method here, which is with algebra tiles. And so this algebra tile here has a width and length of x. So the area of that algebra tile would be x squared. These tiles here are all the same width of 1, but they have a length of x. So x times 1 would have an area of x. So all of these have an area of x. And then these have a width and length of 1. So 1 times 1 has an area of 1. So these are all areas of 1. So what we have all together here is x squared plus 7 x's plus 12 ones. So x squared plus 7x plus 12. And so what we want to do here is actually rearrange these algebra tiles so that they form a rectangle. And if we do that, we're actually going to have to take some of these x's and put them down here below x squared. And so we can do that and look like this. So this is x squared, these are all x's, and then these are 1's. So in this case, we have a rectangle that's formed here with these algebra tiles. So we brought 3 down here and 4 up here, and then 12 came down here. So if we think about the width and length of this entire set of algebra tiles now, this has a length of, let's see, this part here is x, then 1, 1, and 1. So that length there is x plus 3. Up here, we have a length of x here, and then 4 1's. So it'll be x plus 4. Which means that we can rewrite this quadratic as x plus 3 times x plus 4. But I want you to notice a couple things here. One is these two numbers, 3 plus 4, so we had 3 down here and 4 up here, added up to be the 7x, right? We had 7 of them, but we split it into 3 and 4. The other thing I want you to notice is that the 3 times the 4 resulted in 12, which was the number down here. Because we had to create another rectangle, a smaller rectangle down here, 3 by 4. So the two numbers that we break up the middle term into, so the 7x was the middle term, right? So we broke up the middle term into two different numbers. They added together to give you the 7x, and they multiplied together to give you the 12. So that's really what we're going to be doing here when we think about solving these quadratics. So let me give you another example here. How about x squared minus 5x minus 14? So in general, we said we need to think of two numbers that multiply to give us negative 14 and add to give us negative 5. If you go back to, you think about algebra tiles. So those two numbers are actually going to be the numbers in our parentheses. So x times x, we think about the distributive property, x times x will always be x squared. And then, again, we're thinking of two numbers that multiply to give us negative 14 and add to give us negative 5. So let's think of all the things that multiply to give us negative 14. It could be negative 2 and 7, positive 2 and negative 7, 14 and 1, or 14 and negative 1, or negative 14 and positive 1. So those are really the only options of things that multiply to give us negative 14. Now, which of those two sets, or two numbers also add to give us negative 5? And the only one that does that would be this option right here, 2 and negative 7. So therefore, we can write that in our parentheses here. So it'll be x plus 2 and x minus 7. Now let's check to make sure that we got this right. And the way we can do that is multiplying it out like we did in our last video. So we're going to strip the x inside here. We're going to strip the 2 inside here. So we get x squared, x times x minus 7 plus 2 times x minus 7. So it's going to be x squared minus 7x plus 2x minus 14, which simplifies to x squared minus 5x minus 14. So you can see where the 2 in the middle kind of separated here into negative 7 and positive 2. So that checks out right, because that's what we started with. So we can always check our factoring by just distributing it back out and see if we end up with what we started with. So that's a great way to check our work. Okay, so let me give you a chance to try one. Take a second and try this quadratic. Again, we're trying to think of two numbers that multiply to give us 28 and add to give us negative 11. So take a second and see if you can do that. All right, so in this case, we're thinking about the factors of 28. So think of all the pairs that add or multiply to 28. So we have 28 and 1, we have 7 and 4, and I think that's about it. 2 and 14. So those are really the only options there. or the negative of both of those. So negative 28 and negative 1, negative 7 and negative 4, negative 2 and negative 14. But just know that when we're trying to multiply, give us a positive number, that we're going to work with two numbers that are the same sign. So that's a really good kind of thing to remember. When we're trying to get a negative number, like we were in the last example, one's going to be positive and one's going to be negative. So just keep that in mind. Okay, so if we're trying to add to give a negative 11, we're going to have to pick one that's got both negatives here. So it's going to end up being, if you look at it, negative 7 and negative 4 do that. So that means this factors into x minus 7 times x minus 4. All right, so hopefully you got an idea of how to factor a quadratic when the leading coefficient is 1, meaning when this number right here is 1, or it's not written, it's an assumed 1, you can factor just by thinking about what multiplies to give us the last term, c, the c term, and what adds to give us that b term in the middle. When a is not 1, though, we've got to treat it a little bit differently, all right? So when a is not 1, in this case 8, we have to do something a little bit different. But before we actually get into that, I want to remind you of how we distribute something like this. So to distribute something like this, we would want to, like in our last video, multiply 2x into this parentheses and then multiply 5 into this parentheses. So we're going to distribute both of those. So we're going to get 2x times 4x minus 3 plus 5 times 4x minus 3. So when we distribute both of those, we're going to get, let's see, 2x times 4x is 8x squared. 2x times negative 3 is negative 6x. And then plus 20x and minus 15. And of course from there we can simplify by combining like terms. So it'll be 8x squared plus 14x minus 15. So in our last video we talked about how to do this and all the intricacies of that. But I want you to notice that if we were to go backwards, and that's what we're going to try to do here in a second, we're going to go backwards. So we would first split up this middle term into 2, right? And then from there, we can factor different things out to go backwards. So that's going to be our main process here for factoring with a leading coefficient other than 1. All right, so let's see if we can do it with this one, and then we can kind of go back to that screen and see if we can make some comparisons. So here's what we're going to do. We're going to take this quadratic, 8x squared plus 10x minus 3, and we're going to split up this middle term into 2. As we go back to that last example, thinking about that and how we had 2, and then we went backwards from there. So we're going to think about what two numbers are we going to put here. And here's how we can do this. Those two numbers need to multiply to give us a times c, which is negative 24. So that's the new number that we're trying to multiply to get, whereas we're going to try and add to get 10 still. So let's think about the multiples of, or factors of 24. Negative 24. So it'd be negative 8 and 3, or negative 3 and 8, 12 and negative 2, or negative 12 and positive 2, and 24 and 1, or negative 24 and 1. So which of those add to give us 10? And you're probably looking at it right here. Positive 12 and negative 2 add to give us 10. So that's how we're going to split up that middle term. So we're going to have 8x squared plus 12x minus 2x. So we've split up that 10x into these two. And it's got to be those specific two values that we split those up to. The order, though, doesn't matter. So you could have put negative 2x here and then 12x here. It would work out exactly the same way here in just a second. You'll maybe be able to see that. Okay, so from here, what we're going to do is we're going to factor out what we can from the first two terms and factor out what we can from the last two terms. This is what we call factoring by grouping. And that's why it's factoring by grouping. Because we're grouping the first two terms and factoring out what we can, and grouping the last two terms and factoring out what we can. So GCF, a greatest common factor from these first two terms, is going to be 4x. So we're going to factor 4x out of these first two. So that's going to leave us with 2x plus 3. And if you're ever uncertain, distribute this back in. 4x times 2x is 8x squared. 4x times 3 is 12x. So we did, what we should have done there. In our last two terms, we can factor out a negative 1, is really what it is. And that's going to leave us with 2x plus 3. Every time you're factoring by grouping, these two should be identical. If these two don't match, these parentheses don't match, then something went wrong in the previous step. You need to go back and check that. Because what we're going to do now is we're going to factor out what we can from the entire expression. So that's going to be 2x plus 3, because that's what's in common here from both terms. 2x minus 3, or plus 3. So we can factor that out, leaving us with 4x minus 1, which is the factored form of that quadratic. But I hope you recognize this step right here. All right, and in fact, I'm going to rewrite this because the order doesn't matter in which we multiply these two things. So if we were to distribute this out, we would multiply 4x times this whole parentheses, and then negative 1 times this whole parentheses, right? Well, that's what we have right here. So kind of going back to distribution in our last video, I hope you see connections between what we did then and what we're doing now. We're going backwards every step. We're undoing and going backwards in those steps. So connecting what we did here with what we did here. All right, can you follow this backwards now? Okay, well, we're going to think of two numbers. If we think about this backwards, we're going to think of two numbers that multiply. Let's see, 4 times 15 is going to be 60, so 8 times 15 is 120. So we're thinking of two numbers that multiply to give us negative 120, that add to give us 14. And that's going to be, well, you already see it up here. It's going to be 20 and negative 6. And so we would split the 14x up into 20 and negative 6. And then we would factor out what we can from here. We'd factor out a 2x from here. And we'd factor out a 5 from here. And that would give us back up to that step. And then from there, we'd factor out from the entire expression what's in common there, which is 4x minus 3. And that would get us back to the top. So really thinking through this whole idea of distribution, but in reverse, can help us in factoring. Let me give you a chance to try one. I know we've only seen one example, maybe two if you think about the one in reverse, but try this one and then we'll go over it together. All right, so in this case, we have 6 times negative 5 is negative 30. So we're trying to think of two numbers that multiply to give us negative 30 and add to give us 13. And we're going to use those two numbers to split up that 13x. So 30, factors of 30 are 5 and 6, 30 and 1, 15 and 2, those. And so you want to think about what add to give us 13. So add to give us 13. 10 and 3 is another one, right? And that one's actually going to be the one that works here. Is 10 and 3, but both, let's see. Actually, it's going to be 15 and 2, isn't it? Yeah, 15 and 2, because we had to add to get 13. And so the 10 and 3 doesn't work because you have to multiply to give us negative 30. And 10 and 3 multiply to give us positive 30. So we have positive 15x and negative 2x. Again, the order in which you put those does not matter. All right, so from there we can factor out what we can. So we have 3x from here, leaving us with 2x plus 5. And a negative from here, negative 1, leaving us with 2x plus 5. So kind of similar to that last example where it was a negative 1 that we factored out over here. All right, from there, we can factor out 2x plus 5 from the entire expression, leaving us with 3x minus 1. And that is factored form for that quadratic. All right, so take a second and try this one. All right, so in this case, we're actually trying to get positive 30 this time. And so we're trying to think of two numbers that multiply to give us positive 30 and add to give us 11. And hopefully you were able to come up with positive 5x and positive 6x. Because 5 and 6 multiply to give us 30, but still add to give us that 11. From there, we can factor out what we can from each. I'm going to factor out, let's see, a negative 5 here, 5x. That's going to leave us with 3x minus 1. We can factor out a 2 from here, so plus 2, leaving us with 3x minus 1. Again, we're left with the same thing left over in both parentheses. So now we can factor out what we can from the whole entire expression, which is 3x minus 1, leaving us with negative 5x plus 2. Now, I want you to go ahead and know that yes, this is a factored form, but another way to do this would be to take a negative out of this one, because a lot of times you don't want a negative coefficient here in front of x. So you can take a negative out of that parentheses and put it out in front. So another version of this would be negative times 3x minus 1 times positive 5x minus 2. So it's just another way to write that one. Okay. Again, if you wanted to check yourself, you can multiply those out and see if you get back what you started with. All right, last one here. Take a second again and see if you can solve this one. All right, so in this case, we have 9 times negative 8 is negative 72. So you're trying to think of two numbers that multiply to give us negative 72 that add to give us negative 6. So negative 72, one of the factors of negative 72 would be negative 12 and positive 6. So negative 12, positive 6. From there, we can factor out what we can from both pairs, both groups here. So from the first group, we can factor out a 3x is the greatest common factor there, leaving us with 3x minus 4. And then from here, we can factor out, let's see, a 2, leaving us with 3x minus 4. So again, it's a good indication that you're on the right track because those are equivalent in the parentheses there. So this is equal to this is equal to, we can factor out a 3x minus 4 from the entire expression, leaving us with 3x plus 2. All right? So I know that can take some time to get used to and take some practice, but hopefully you can figure out this whole idea of factoring by grouping for quadratics with a leading coefficient that's not 1. When the leading coefficient is 1, it's a little bit simpler. You can just think about the two numbers that multiply to give us C and add to give us B. The main reason why I'm showing you factoring by grouping is also because it's very applicable in other situations. When you get to integrated 3, you can use factoring by grouping to factor things like a cubic expression as well. And so it can come in handy there. So hopefully we gained our goal for today, which was to convert a quadratic from standard form to factored form. And one of the benefits of that is we can now tell what the zeros are of our quadratic. So if you're given something in standard form, you can factor it to find those zeros.